Right, so in the video that I've made here, it's another practical demo, and it's designed to show or explain to people who don't understand just really simple, basic, everyday physics, how certain things work. Who go around promoting flat Earth basically because they just don't seem to have a grasp of these simple things, and there are certain people who are really vocal about that in flat Earth, and just in it, same as with the previous video about moon visibility, that was all because many of these vocal people, they really like to tell everybody how knowledgeable they are and how much research they've done and how nonsensical the heliocentric model is and stuff like that. And yet they completely and utterly fail to grasp these very, very simple things. Like in the last video, as I say, it was trying to understand how a secondary object could be, a third object could be seen from a second object while being lit by the first, which is really, really simple, straightforward spatial awareness that children grasp as they're growing up. But for some reason, these adults who call themselves critical thinkers and who are out there all the time promoting flat Earth and saying they're smarter than every physicist and all this kind of nonsense, they don't get it. So they're running around, on the one hand, making themselves out to be these enlightened individuals and how clever they are that they've figured out something that science is lying to them, but they just don't understand these very, very simple things. And this is another one, and it's related, which is why I'm mentioning that previous video. And another way that it's related, apart from the subject matter, is by the people involved, the people that promote this ignorance. And I'm going to show one of those people here, and just quickly go over why it is that these are the kind of things that people say that end up making it necessary to make the kind of videos that we're doing here. So in particular, we're going to be talking about Del from Beyond the Imaginary Curve, who, if you get any familiarity with flat Earth, I'm sure you'll already know who it is. If you're somebody who happens to be watching this video and you don't know anything about any of this stuff, there's no point going into it all just now. The main thing you need to know is just what I'm just about to show from a wee series of clips I've got lined up and ready to play here regarding the specific subject matter. So Del is one of those people. He likes to tell everybody he's a science guy. If you ever get round to watching these videos, if you haven't already, you'll hear him make this claim over and over and over again. He's a science guy. However, despite his lengthy time on YouTube and his several hundred videos or whatever he's got up, he never does any science. And he will constantly badger other people to do science. And he will constantly tell you how much he understands science and how wrong scientists are. But he never does any science himself, and none of his arguments come from a scientific understanding and a rebuttal. There's no rebuttal based around physics or science or anything like that. It all comes from ignorance and incredulity, and we'll see that in a minute, as I say, as it relates to this topic, which is, it's all about the reflection of light from the moon. So a lot of flat earthers really don't believe that, a lot of people don't even believe the moon is where it is and that it's made of what it's made of. But in particular, the thing that we're addressing here is, so many of them will tell you that it's not possible for the moon to be reflecting the sun's light. So this is what this video is really about, but I want to show you this stuff here, because if you don't already know about it, this will give you a good grounding in what we're dealing with, what the video is about. And it'll just show you in general, although we're using Del, but he's just a representative here of a much larger group of people who all parrot the same ignorant idea about how light works and the fact that the moon couldn't reflect light. So, starting with this first clip, you'll see here, it's a video he made. This was done in January, I think. Back January, so it's a good few months old. But I always remember it, it's one of these things that sticks in my mind when people say, they just get really simple things totally wrong, but they're really arrogant about it and they didn't, insistent that it's everybody else that's stupid. Anyway, so beware of moon claims. So this was obviously quite a longish video, like 20 odd minutes. So he's talking about various things, but we've got it queued up here, and we'll just let you hear what Dell is saying very specifically because it relates to why the video is being made.
Another anomaly, and I will set up an experiment to show that rock, right, does not reflect light to light up other areas, okay? That's just not reality, it's fucking ridiculous. So again, another anomaly that you can prove over and over again that can't be the case.
Okay, so according to Dell, 7 months ago, it's an anomaly that rock could reflect light. It's fucking ridiculous. And it's an experiment you could set up to prove over and over again that it isn't true. Of course, he's never done that. He's never ever produced any videos regarding science and experiments or anything. There's no video available from Dell that actually shows practically anything that he claims, even though he constantly tells you he's a direct realist and that's the way to figure things out, is to do it all yourself. You'll never find a video on Dell's channel that does this, apart from the one and only thing, which is how he started off, which was showing water falling off a ball, which he claims disproves gravity, but actually proves that gravity is doing exactly what we all say gravity would do, which is pull the water off the ball to the surface of the earth. So he's got one failed experiment and nothing else. But what, digressing a bit here, because we don't really want to talk about Dell, to be honest. It's more about the subject of the moon and the light. But you need to really get a good focus on the attitude you're dealing with here. He's repeating something that he just doesn't know to be true. He's done no physical experiment to demonstrate whether his thoughts on how it ought to work are true. But he's sitting there telling you he'll do it, but he's never done it. That's 7 months ago, he's still never done it. And he never will. And he's happy to tell everybody else who thinks it might be true that they're fucking idiots for thinking that it might be true, basically. And if we scroll down, I just want you to pay attention to a couple of comments here. So, Cheech, in a later video this will become relevant, but he says here the moon's brightness is due to the sun. It's logical. So, he's stating that, what we know and the obvious, that's reflecting the light from the sun. And then another user, Row Wi-Fi, or however you pronounce it, how can rock be reflecting light onto something else? I'll give you the repeatable experiment. Go outside at night and shine a torch onto a rock. Can you see it? That's reflected light. Shaking my head. Now, this is the main thing that really matters here. Everything you see, everything is reflected light. So to say that any object, any particular material or texture, whatever, doesn't reflect light is actually in complete contradiction. Observable physical reality for everybody apart from the blind, which is that if you can see an object, it's reflecting light. So it's a very, very simple and easy to determine fact of physics. But Dell's in denial of that. He doesn't understand that if you're shining the torch at a rock and you can see the rock, then yes, the light is being reflected. Or else, if it wasn't, you wouldn't see that rock being lit up. But anyway, so he's been told in some form or another the basics here. And as we'll see as I click through, things like this just don't wash with people at Dell. So anyway, the next video, something that was done, I don't know, a few days later or whatever. Next day, it kind of crops up again. So
look at this waste of time with this fucking moon thing. They don't address the facts. They don't address the claims that they make. That it's solid and made of rock and rock reflects light and all these fucking crazy things. Right? They don't.
Right, so here we go, he's at it again. Oh, that rock reflects light and all these crazy things. Now notice that it's just a complaint. He doesn't actually give you a reason why rock wouldn't reflect light. We actually already know that this is not going to be true, but he's happy to sit and get angry about it. And he pulls his wee funny voices and his silly faces because that's what he's got to work with. He's got to be arrogant about it and he's got to be incredulous about it. But the one thing that he cannot do is actually say, why it wouldn't work, give you any physics, give you any science, do any experimentation. So, he's led up by saying, all right, rock can't even reflect light. And then in a follow-up, he's repeating himself and saying, oh, it's ridiculous. It's a ridiculous notion that rock would reflect light. So then, a little while, let me see, a few days later, so, he's done a comment response, and the comment response relates back to this original video here that we played at the beginning. And I've got it queued up here twice to play. This is his responses to the two comments I pointed out. So they're not in order, but it just makes a bit more sense to have them this way. So this is the first one.
234 cheats again. The moon's brightness is due to the sun. It's logical. What?
I mean, there you go. That's it. I mean, you don't get anything more sensible in regards to this subject at all. Just pulling funny faces, putting on silly voices, acting like it's an incredibly stupid thing to say, but he's got nothing to say to actually defend what he is claiming, which is the opposite, obviously. He's trying to say rock won't reflect light, but he does fuck all to actually back up his own claim. But he's totally arrogant about it. He's full of ego. He's just like, oh, that guy's just totally stupid and I know better than him. But he's got nothing to say back. So that was his response to the first comment as you scroll down. And then this is his response to the second comment.
Roife, how can rock be reflecting light onto something else? I'll give you the repeatable experiment. Go outside at night, shine a torch onto a rock. Can you see it? That's reflected light. Now you can see it illuminated, but it's not shining down onto anything else. Are you people really that fucking stupid that you don't understand the claims that the heliocentric model's making?
Right, so there it's just, right there in front of you. So he's not putting two and two together here at all. He's completely convinced that he's right without any experimentation or proof. Again, he's full of incredulity. That's his thing. So he's wrong. He doesn't know how this works, right? He's in his own sentence there. He's proved that he's got these contradictions going on, because what he's saying is, oh aye, if I shine the light on the rock will be lit up. Well, how could you possibly know if the rock was lit up if the light that was hitting the rock wasn't entering your eye? That means it's reflecting back at you. But the problem is he's doing a thing that a lot of flat earthers, they all make the same mistake, which is that they seem to think there's a difference between the light that's reflecting back in your eye and whether that light would reflect onto other surfaces around it and be visible. Now, obviously, if you're talking about very small orders of magnitude of light and small surface areas and things like that, you're not going to get a very good result. You need to think about this on a bigger scale, and when you think about what you do see with the sun and the moon and the earth, you compare the way the entire earth, or half of it at a time, is lit up by the sun and how it's lit at night by the moon. Now, you might get a bit of a glow from the moon, but if you compare the amount of light you're getting from the moon to how it is from the sun during the day, there's a massive, massive drop off in the amount of light. So again, if you scale that back down to a very low magnitude of light on a surface which, is reflective because everything is, but is not what you would class as maybe a highly reflective surface compared to obviously mirrors and shiny objects and things, highly, very white objects and things like that. You're not going to see like a big massive pool of light off a wee stone or a rock, but you're going to get some reflected light. Again, if you didn't get reflected light, you wouldn't be seeing the rock. So he's mocking this guy who's told him the facts, the basic facts, and he's completely just full of himself about how right he is and how incredibly stupid that person must be for saying the truth. And the only way he can be doing that is obviously because he doesn't know. If he doesn't know, that makes him ignorant in the proper sense. And his only way to deal with it, he doesn't come back with any science, he doesn't come back with any facts. I mean, there wouldn't be any facts to support his position, but he could try. He could try and give an actual physical explanation of why it wouldn't be possible. But he doesn't. He's just incredulous. So it's ignorance and incredulity. And as I say, we're using him as an example. We're not going to be sitting talking about Dell all night. This is just the kind of the forward, if you like, the reason why we're going to have another, the other half of the video, because it represents what you're seeing here with this particular person. It actually just, it floods over into a lot, maybe not all, but a lot of flat earthers. Anybody you find who has a problem with the moon reflecting the sun, which is a fair amount of people, unfortunately, it's all the same misunderstanding, the same misconception, the same half-baked idea of how light works. They've got the first half where they can see things, but they don't relate that to the fact that the light itself must therefore be working its way from the object to you, and it's not magic light that can only follow one singular path into your eyeball and ignore every other object round about it, any of that stuff. So this is what you're dealing with. This is why the video exists. So I thought it was kind of important to lay that groundwork, if you like, and explain why it is we're going to be looking at this. And just quickly before we put this off and I put the other half of the video on, as well as what the guy in the video has to say, you can just look at this first comment from this user here, and you can see it's the same attitude, the same ignorance. That comment about the moon being illuminated by the sun made me laugh out loud. Well, loud, obviously, that's meant to be. These morons really should do a little research before making such claims. I mean, the hypocrisy and just the sheer ignorance involved in that comment is ridiculous. You're obviously looking at somebody who hasn't got the slightest clue, just like your guy in the video, and probably like most of the people who are all supporting whatever he's got to say. Same thing. They're all supporting these silly ideas about how things work in physical reality and making it like it's the other people that are ignorant when they clearly haven't bothered their own arses to go and research it themselves. This is a common theme. They just go and look at other flat earth channels, repeat the same things that each other say. They don't really actually do any proper research. It's all YouTube nonsense, regurgitating the same shite, basically. So anyway, that's enough of that. So in this initial shot through the GoPro, you can see everything that's going to get used in the test, which is a table full of materials, a garden ornament, some cushions at the background, a secondary camera, and the object against the wall that we'll be trying to bounce light off of or onto. The table contains various materials, an old trainer, a neoprene bag, some stones, and a little white porcelain bowls. These are all obviously meant to have different surface textures to try and work with the light. And then the main thing was this garden ornament, which is the one I want to use to, in a sense, replicate the moon, because you can see it's got a very sort of similar look and feel to similar sort of surface texture and colouring. So it seemed like the best thing to use as the kind of primary source to see if we could get light to bounce off it. It's got a slightly curved surface, it's got a textured surface, it's a kind of mottled grey, so it's about as close as we can get to a sort of scaled down representation of the moon. And then on the table, the different materials include a pile of stone, so this was to take the stone thing a bit further as well. A pile of loose stone chips, so obviously a very irregular surface, which obviously makes it much harder in theory for the light to be reflected off it, especially in the minds of people who think that it's impossible on a large spherical object. So this was a good way of really kind of driving home the point. If we could make it a successful reflection off a pile of loose, rough stone chips, then it really it shows you just how effective that material can be. And then, of course, it has different ways of demonstrating just how much it changes depending on the material. So there was a little white porcelain bowl, which is obviously highly reflective, and we would expect to get a good result with that. A small black neoprene bag, so that's obviously an absorbent texture, being black and slightly porous. So again, a really good way to test how much light actually reflects from different surfaces. So now it's not a light surface, it's pretty far from what you would expect to think when you're thinking of a reflective surface for light. And then the old Converse trainer, same idea. It's a black rubber sole, slightly smooth, slightly rough. Again, black, more of an absorbent colour to work with. So again, that was just a good way of having a good control for the overall test. And then with the cushions, I wanted to again kind of cover both sides of this. So a cushion, again, not something you normally think is reflective, and the first one has got a slightly smoother surface and a lighter grey kind of colour. But the larger one, that's a much more interesting one to try and make this work with, because it has lots of little individual hairs essentially, and it doesn't sit as a smooth surface. It all bundles up, and then of course the actual colour of it goes from a kind of light grey to dark grey. So there's a lot of ways that the light you would maybe expect to be deflected and absorbed and so on from a material like this. Again, very far from what most people would consider a reflective surface. So those were all the materials that I wanted to work with to give us a good set of parameters to get this thing tested out. But as I say, the garden ornament is the main thing, because it's the closest we can get to replicating the moon, and then the stones were a backup for that, just because the main material we're concerned with is stone, because it's a big complaint that kind of material could never possibly reflect light the way we see it with the moon. So then over at the wall, what I've done is I've placed this object so that it will give us a void within the light. So any light that's reflected towards that wall, if we're successful in doing that, the object will create a void, which of course will create a shadow on the wall. And then I've got my secondary camera pointing at that, obviously, and that's there to get a backup for anything the GoPro can see a bit closer in, focused on just on the wall itself all the time, so that we can get a good recording of whenever this might be successful and demonstrate light bouncing off whatever object at the time. So in the initial video, as I was talking it through, I was just explaining here that this is the area I was going to place the objects and try and get the light to come in from the direction which would be behind the camera just now, bounce off at an angle and head over to the right towards the wall. And obviously if it's successful, it will light the wall up green and leave the shadow of the symbol on the wall. So now in this next section, what I'm doing is just I want to explain how the beam is affected by reflecting off of different surfaces, and demonstrating how the main beam itself works. It's a pencil beam, and the fact that the beam itself isn't going to contaminate the results the way a normal torch would. So at the moment I've got it bouncing off of something that's reflecting the light back, which is why we can see the green light on the wall to the left behind the symbol. But in a moment what we'll do is we'll switch it around and point it somewhere where the light isn't going to be reflected back, and then that way I can show that the actual the beam from the laser, the very thin beam of light in itself, doesn't emit enough light around its exterior, I feel like, to contaminate the results by creating a spill of light that will light up the wall. So basically what I've done is I've just flipped it around, pointed it in the opposite direction out into a little hallway at a dark object, and that way with the beam running in front of the symbol, I'm able to show that it's not contaminating the results. We're not getting light on the wall if we don't actually point it at something that's reflecting. And then of course, just to be thorough, I've moved it again, pointed it at the white door, made sure there's plenty of reflection coming back. You can see that the difference is just massive. So if it's pointing from a reflected surface, you can really see that the light getting bounced back. And if it isn't, the actual laser beam itself just isn't strong enough to create this kind of shadow and the pall of green light that you're seeing. So on to the first test, and I'm using the small white bowl, which is the most obvious reflective surface that we've got. So you expect good results with that. I've got the camera on, it's set up at a slight angle so that hopefully when I fire the laser at it, it should bounce off at an angle. So obviously switch the light off and go for it and see what the results are. So you can see straight away the beam, it's just scattering, it's highly reflective. You can see the light lighting up everything. So you can see the shadow of the other camera. You can see pretty much every wall, and if you could see up above, you'd see the ceiling as well. It's just reflecting light everywhere. So a very clear and obvious result from the white porcelain bowl, which is just exactly what you would expect, basically. So the next thing that I worked with was the light grey cushion. I wanted to compare, still a relatively light material, but going the other way with the type of actual surface and texture that it was. So it's a light color, but it's an actual material as opposed to a solid shiny object. So as you can see, no problem at all with that one. So straight away, even though it's a light color, we're showing that the kind of material that most people wouldn't think of as being reflective is actually quite highly reflective. So this is just a grey throw cushion type thing, and it's reflecting light really well. Really nice sharp shadow in the wall. It's covering the whole wall, not just the back wall with the symbol, but the other one with the camera, very nicely defined. Lots of light being cast. So yeah, that one works really, really well. So now we're moving on to the garden ornament, which is really our main subject because it has a slightly curved body. It's mottled grey. It's got the kind of rough surface texture. So it's to scale, it's the nearest thing we've got to simulate the general sort of surface and shape of the moon. And as you can see, while not quite as defined as the previous two, there's a lot of light being reflected off of this thing. And the reason it's kind of jumping around is because of that rough texture and the different shades of grey that are contained in the stone. And so when it moves on to the slightly lighter patches, you'll see it as a bit of a better reflection, and when it's in the darker patches, it's a bit less light reaching the wall. But overall, you can see as the light moves around, lots of light getting flung off of this stone object with a textured, rough, slightly curved surface, and it's working fine. It's reflecting quite a lot of this light across both walls, and you can see the shadows pretty well. So this being the main test, this is really the one that matters. But we really want to drive home the point that it really doesn't need to be a light texture, a light surface color to reflect light. Everything you see, as I say, is reflected light. So really, you would expect to get a certain amount of response from all different materials. But this really is the main thing that we need to concentrate on with regards to anybody who has any problem understanding why we know that the moon reflects light from the sun. If you've got any doubt about this idea that stone and rock can reflect light, this is just to show that it's very, very wrong. It's a misconception. So now we're moving on to this pile of little stone chips that we've got. And as I say, the reason for this is that we really want to look into the idea that this kind of material, even when it's a really uneven surface, which you think would be really difficult to work with, would break the light up and make it very hard to reflect light in any sort of reasonable manner. If this works, it obviously shows what we're trying to explain here. And as you can see there straight away, this is the laser beam is bouncing around off all these little rocks in and out the cracks in between and stuff like that. And any time it's making contact with something towards the front, whatever's there, it's got enough capability of projecting the light that's hitting it, off and onto the wall at the rear and at the side. Again, I mean, just people have this strange idea that for some reason rocks and stones, things like that, just wouldn't reflect light, and this really sort of demonstrates it really well that you have this pile of loose stones, and you can really see there's a lot, as it flashes around, there's a large amount of light being reflected off of these across both walls, and you can see the shadows really nicely defined. So, it's pretty clear what's happening there. That the material is perfectly capable of doing it. So moving on to the darker textures and surfaces, um, we've got the neoprene bag first. Now, unfortunately, I ran into a problem here. It does work, but the issue I've had, the first thing is that the angle was a bit wrong. So you'll see straight away it's hitting it at such an angle that it's going straight onto the wall behind with the secondary camera. But if you look carefully as well, you can see the shadow from the bag causing a line on the table beneath, and then the actual light that's being reflected onto the table from the bag. So it's quite a lot of light that's actually being reflected off of this dark porous surface texture. But the other issue was that the camera itself just wasn't sensitive enough to pick up the light the way I was seeing it with my eye. So I switched the angle of the bag slightly to try and get a better reflection of light over onto the back wall. And although I was able to see it, it wasn't especially bright, but it was easy to see. But unfortunately, the camera couldn't pick it up as well. So what I've done here is I've taken this section that I'm talking about in the video, and I've just upped the saturation a bit so that the green tones will be a bit more visible in this clip of video, and you can just make it out on that back wall now that the saturation's up a bit, just to make it a little bit more visible. So yeah, it's still working even with a black neoprene bag. So moving on to this next test, it's the shoe itself. So I'm going to use the rubber sole of the shoe. But it occurred to me at this point as well that some people might slightly be doubting the idea where the light source has come from that's reflected on the wall, and it might have been bouncing off the table and then going onto the wall. So what I've done is I've moved the shoe over to the edge so that when I'm firing the lasers, you can see there it's just the sole, it's not bouncing off the table. And I'll do a demonstration of that. I'll fire the laser off the sole and show how that looks, and then you'll see in this next section of video that I make a point of shining the laser off the table as well, and you can compare the difference. So obviously from the last clip I'd learned this problem with the camera not picking up the reflection too well, so I've done the same thing here and bumped up the saturation and lightness just a little bit so that we can see that when there's a small amount of green light you can spot it on the other wall. But initial test just mainly pointing towards the wall where the second camera is, with a little bit of spillage over to the main wall that we were trying to get to. And then just for comparison, as I said, bouncing off the table, massive difference. So it's really noticeable when that's the source of the reflection, and then off the wall itself of a very bright white surface. So you can see when I move back to the sole of the shoe, it is just the light that's coming from the sole of the shoe, which is primarily bouncing off the wall with the camera on it, which is the main thing. We just want to see that this even a really dark material like this can reflect light, and it is capable of doing it, just to a lesser extent. So as I say, everything is reflecting light, so it's working fine. So now on to the final test, which is this large grey fluffy cushion, which as I say, I've put this in here because I think it's a really good way of showing that a surface which is very different from what most people would consider to be reflective is actually capable of doing just the same as what everything else has been doing in reflecting light. It's a hairy kind of texture. It's all lots of little individual threads. It's got folds in it. It goes from light grey to a very dark grey. So there's lots of opportunities there for the light to get absorbed and diffracted or whatever. Just scattered around, and just something you wouldn't expect to be bouncing light off it. So it's another good way of showing that the behaviour of light when it's interacting with objects is maybe a bit surprising, and it does actually reflect very, very well off unusual objects, and it really doesn't work the way a lot of people seem to think that it does. So once this is all set up, you'll see straight away, there you go, nice defined shadow on that back wall there. Now the cushion is kind of hanging down over the table, so we'll get this first, and then I'll move towards the front. And when I move towards the front of the cushion, you should be able to see more of a reflection towards the other wall. But the amount of light you're seeing there is just obviously pretty impressive for the kind of object we're working with. So as you move, that's me moving towards the front of it. Now, as I said, I had problems with the camera registering as well as what it could be seen with the eye. When I was actually doing this, I could see this really, really well. So again, what I've done, I've bumped up the settings on this clip just to make it a bit more visible in the final video. But there's no doubt anyway, even just from the initial reflection onto the wall closest with the camera at the background, that even this object is capable of reflecting light. So as I've shown through the whole video now, I've used all these different surfaces, different colours, a very bright reflective surface, a mottled grey textured stone, a pile of stones, black rubber, black neoprene, and now a folded kind of large, hairy, darkish grey cushion, and every single one to some extent is reflected light, and several of them have reflected them, especially the ones that matter, really when we're thinking about this whole issue with the moon reflecting light. The pile of stones and the stone ornament, no problem at all, very good reflection off of them. So if you get any doubt about how this would work with the moon, that should hopefully solve the issue for you, especially when you consider the fact that this little laser pen is getting no comparison in terms of brightness when you compare it to the nuclear furnace of the sun, which, as we know, lights up half our planet and gives us all heat energy and light, etc. And the object it's bouncing off of is a planetoid, which is like a quarter the size of the planet we live on. So all things considered, if you've got any issue with the idea that something at such a massive scale, that made materials of the kind of textures we've been talking about here, capable of reflecting light back to the earth from something as large and bright as the sun, this will hopefully just settle that whole misconception for you.